All right, so Google's new Sycamore X2 chip, people are saying it could unlock multiverses, which I gotta say, sounds pretty sci-fi to me. But we're going to try to get to the bottom of this today. We're going deep on this document, all about Google's quantum chip, multiverses, and even the future of humanity and AI.
It's a lot to cover.
It is. But that's why we're here, to break it down.
Yeah, and what's crazy is the Sycamore X2, it's already doing things that would make even supercomputers look like they're from the Stone Age.
No more dial-up then, huh? But what can this thing actually do?
Well, think about this. Analyzing a century's worth of financial data in just seconds, finding patterns no human ever could. This chip solved a problem in 200 seconds. That would take in a classical supercomputer 10,000 years.
Okay, that's impressive. I get that. But I'm still not seeing the connection. How does that tie into the whole multiverse thing?
So quantum computing, it uses these things called qubits, which can be a 0 and a 1 at the same time.
At the same time? How's that even possible?
It's called superposition. And it allows them to, well, it lets them explore a ton of possibilities at once. Kind of like how the many worlds interpretation describes the multiverse.
Hold on. Many worlds what now?
Right. So the many worlds interpretation, it's how some physicists try to explain the weirdness of quantum mechanics. Basically, every time a quantum event happens, every single possibility branches off into its own universe.
So like a choose your own adventure, but for the entire universe.
Exactly. Every decision, every possibility, it all splits off.
Okay. So you're telling me there's a universe out there where I actually won an Olympic gold medal.
It's possible.
I like that version of me. But how does Sycamore X2 actually play into this?
That's where things get really interesting. Because qubits can be in that superposition state. Quantum computers, they kind of embody the whole multiverse idea. They don't just calculate one outcome. They explore a whole bunch of possibilities at the same time.
So are you saying this chip could actually simulate these other universes?
It could be our first step towards that.
Wow. Okay, so we're talking about potentially rewriting our understanding of existence itself. If there are infinite versions of ourselves out there, what does that even mean for things like free will and fate?
It's a pretty deep philosophical question. But even on a practical level, think about the advancements we could make in science and medicine.
You're thinking like simulating the effects of new drugs across all these different universes.
Exactly. We could see which versions work best and in which scenarios.
Okay, yeah. That would be huge for drug discovery, climate modeling, all kinds of things. But this power, are we even ready for this?
It's a good question. Simulating entire universes, maybe even with conscious beings, it definitely raises some serious ethical questions.
It's a lot to consider. This chip could be humanity's greatest tool or its biggest downfall. And I know this document also talks about AI. How does this quantum revolution, how does it play into artificial intelligence?
That's where things get even more interesting. Imagine an AI that can tap into these simulated multiverses. We'll dive into that next. So we were talking about AI and how quantum computing could completely revolutionize it.
Yeah, it's kind of hard to wrap my head around. Like, how could a computer explore different realities?
But it's not about plugging into the matrix or anything like that. It's more about the potential for quantum computers to simulate really complex...
Is the human brain.
Exactly. We could see AI sick that learns and thinks like we do.
Hold on. Are you saying this chip could lead to, conscious machines?
It's a possibility.
Wow.
But even without going that far, the implications are still huge.
Okay, so, what kind of implications?
Imagine an AI that can analyze trends across tons of simulated economies.
So it could predict things like financial crashes.
Before they even happen.
That's a little scary.
Or an AI that could design, 1,000 different versions of a bridge and test each one in every possible scenario.
To find the best one.
The most resilient.
So it's not just about AI being smarter.
Right.
It's about them being more creative.
Yeah.
More adaptable.
Exactly.
Which I guess that's where the risks come in.
Right. What happens when AI not only learns super fast, but also operates in ways that we just don't understand?
It's that whole superintelligence thing, isn't it?
Yeah.
Where the machines basically become so advanced that
they surpass us completely. And if they can use those multiverse simulations, we might not even be able to predict what they'll do.
So how do we even control something like that?
Well, that's the question, isn't it? We need to start thinking about safeguards, ethical frameworks, ways to make sure AI stays aligned with our values, even as it gets more powerful.
It sounds like we're walking a tightrope here. This technology could solve so many problems, But it could also create a whole bunch of new ones.
It's a delicate balance for sure.
I know this document also mentions some of the challenges in actually building these quantum computers.
Yeah, it's not easy.
It's not like we're going to have these things
Yeah.
mass-produced anytime soon, right?
Right, yeah. It's like trying to build a skyscraper. Out of toothpicks, the technology is just so delicate, the tiniest thing can throw it off.
So what kinds of things are we talking about here?
Temperature changes, stray electromagnetic fields, even just vibrations.
So someone bumping into it could actually mess the whole thing up.
Pretty much. These quantum states are super fragile. Any little disturbance can cause them to
Decohere.
basically, they lose all their quantum properties.
Huh, interesting. But this document also mentions some security risks.
Right.
What happens to online security when these quantum computers get even more powerful?
So right now, our encryption methods rely on really complex math problems. That would take a regular computer thousands of years to crack.
Right.
But a quantum computer, a powerful enough one, could potentially break those codes in hours, maybe even minutes.
So someone could have access to, like, every bank account, every government secret.
It's a possibility.
That's a little unsettling. But are people working on ways to counter this kind of quantum hacking?
Oh yeah, definitely. Researchers are already developing new encryption methods, specifically designed to be resistant to quantum attacks.
It's like a constant arms race.
It really is.
We started this deep dive, asking if this chip could unlock multiverses. And I gotta say, we've gone pretty deep down the rabbit hole here. We've covered a lot of ground, from the speed of this new chip, to the concept of the multiverse, to the potential of quantum AI, and the risks that come of it.
It's definitely a lot to take in.
It is, it is.
But it's a good reminder that we're living in a time of unbelievable scientific advancement.
Absolutely.
But with every leap forward, we have to consider the challenges and the responsibilities.
So are we ready for this quantum revolution?
That's a question we all need to ask ourselves.
It's exciting and terrifying all at the same time.
It really is.
Well, thanks for joining us on this deep dive into Google's quantum leap. It's a journey that's just beginning, and we can't wait to see where it leads.